Over there. All right. So now you should be able to see my screen. We should be ready to rock and roll. By the way, thank you very much for joining day 2. You know what's awesome about day 2? Day 2 is great for 2 reasons. The first reason is we get to jump on to doing a lab, which I think is really super exciting. The second thing is Kevin Clark is coming in and he's learning. Kevin, say hi to the crew.
Hello, everyone.
Got a number of people. He's going to be doing some AV stuff with us. And well, he's been doing AV stuff with us for a while. He goes back a long time with one of our directors here at Anti-Siphon. So we're excited to have him help out with these things as well. All right. So with this, let's jump in. All right. So the first thing that we're going to do is go to this specific lab instruction. I'm going to drop this into the Discord server right there. So you guys all know that we're coming to the right place. And I am logged into MetaCTF. So I went into MetaCTF, and this is really important. When you start your VMs, you start with this button right here, not the orange button, not the red button. You don't go down and start them down below, not those. You start with the start all machines. If you get connection errors, like you can't get to your Kali system, it's probably because it's not started. So we're going to do start all machines. All right. So we're going to start all machines. Once you do start all the machines, in the lower right-hand corner, it's going to count down from like 200 seconds. It's kind of a fun little like countdown, you know, it's got that whole final countdown vibe, which I'm going to ask Roman. I don't know if Nicola is on today or anybody from MetaCTF, but I'm kind of thinking we need to kick off the final countdown whenever we start the countdown for getting our VMs up and running. Just be kind of cool. Be a checkbox option, maybe an Easter egg. But once it's done, it says connect via browser, RDP. And then when that happens, this is what you got. All right. This is a server 2022, and you can access your Kali system by clicking on the Kali terminal icon. You can access your command prompt by clicking on the little command prompt in the bottom, and you can access a PowerShell prompt by clicking on PowerShell. Everything's ready to go. It's set up and it's ready to rock for you. And all the instructions, pretty much straight copy and paste. And the first lab that we're going to be doing, because we spent the end of yesterday talking about Linux, is the Linux command line lab. We have 3 terminals. We're going to have where the backdoor is going to be run. We're going to be connecting to that backdoor, and then we're going to be doing some analysis. So we're basically infecting ourselves with malware and then hunting for that malware. So you're going to open up a Kali instance just by clicking on the Kali icon right here. Then you're going to become root. You can copy and paste. Now, when you first start, and you should be using a Chrome-based browser. If you're using something other than a Chromium-based browser, copy and paste may not work really well. So I'm just warning you, you might run into that issue, and that's okay if that happens, because you can open a browser within the VM. And once you get into the browser here, you can just do Strand.js GitHub. Like that. And you can go right into my GitHub repository within the VM, and copy and paste will work inside. But I recommend, if it pops up, do you want to have access to your copy and paste, your clipboard? Click yes, because it's going to make the labs a lot easier for you. So the first thing you're going to do is you're going to become root. Then we're going to create a backpipe. Don't worry what this is. I'm going to talk more about this a little bit later, but a backpipe is a FIFO device file. Ooh, that's a mouthful. And it allows us to create a backdoor on our Linux computer system in one command line shot on that. So we got our bin bash backpipe. We have the backpipe present and accounted for. Should be ready to go. Then you're going to run ifconfig to get your IP address. Now, your IP address is going to be different. You're going to see this brought up again and again and again and again in all the different labs. Your IP address is going to be different. So take note of what your ETH0 IP address is. So you're then going to connect in a second terminal. So then you're going to run a couple of commands to make sure it works, because it's not going to show anything when you make the connection. It's just going to hang there. You have to type something like ls and who am I. At this point, it's time to go hunting for your malware. We're going to open up a command prompt, and then we're going to become root on our Linux command prompt, and then we're going to start with LSOF. We talked about this command yesterday. List open files is one of the most powerful commands on a Linux computer system for hunting for malware, because everything in Linux and Unix is a file. So to have a tool that gives us the ability to list open files is incredibly powerful. Then we're going to drill in on a process ID to get what are all the open files for that suspicious process ID, and your PID, your process ID, will be different. Then you're going to run PSAUX. We're going to look at all the processes. You're going to see your netcat listener there. Then we're going to CD into the proc directory to the PID number that's recorded up above. So you can see here I have a PID of 3216. Going to move into that PID. Then you're going to go into the directory, you're going to type ls. Once again, remember your PID will be different. And then we're going to run strings against the executable to print out the human readable strings. You're going to hit spacebar and go down until you start seeing usage information for netcat. And that is the lab. This lab is going to take us about 15 minutes to do. So let's go ahead and let's put 15 minutes on the clock. I don't know if we trained, Ryan, I don't know if we trained them on how to put the clock up. Did we? It's all right. It's all right. We got it. We got it. It's cool. We've got the 15 minutes. So let's go ahead. We're going to do 15 minutes. We're going to come back, and then I'm going to do the walkthrough with more detail and slowly. All right. So get rolling, everybody. I'll see you in 15 minutes. Here we go. All right. Timing on that was just, I think we all have to agree, the timing on that was absolutely spectacular. So well done. All right. So let's go ahead and let's jump into this lab and walk through Linux command line getting started. All righty. So we have our Linux system here. I'm going to open up another Kali system. We got to have 3. So I'm going to change my settings. We're going to change the appearance on all of these. Go ahead and go. There's one more, and then I'm going to get one more here. And now I have 3. So basically what we're going to have is the compromised system. We're then going to have the kind of attack system that's connecting in, and then we're going to have the hunt system. And we're going to be doing the actual hunts on. So we have 3 separate windows ready to go. All right, so in the first window, we are going to become root, like so, that. And then we are going to do make node backpipe P. Now, if you remember yesterday, I said everything in Linux and Unix is a file. Everything in Linux and Unix is a file. And there's different types of files that do different things, right? Like you can have a device file that is your mouse. You can have a device file that is your keyboard, right? These are all files technically, but they do different things. So what we're doing with make node is we are making a FIFO device file, first in, first out. And basically the reason why this type of file is in existence is so that you can have applications communicate with each other without having to open up a TCP/IP socket to do it. So imagine if you have 2 programs, they need to exchange data, but you don't want to have a network connection. To do that, you can do a FIFO device file, and that's what we're doing. So make node allows us to create these special device files. Backpipe is the name of the file that we are using, and P is what denotes that it's a FIFO device file. We could have named it something other than backpipe. We could have named just about anything we wanted. So now we're going to create our little netcat listener backdoor. So this is a backdoor one-liner. There's a ton of them out there, but what this particular one does, it uses bin bash, and it hooks bin bash into a netcat listener, so the netcat listener can funnel that data directly into bin bash. And there's a bunch of them out there. Like if you just do a search for pen test, we just kind of do that. You can do Here's a bunch of one-liners, command and control one-liners. All these different ones are out there. You can do backdoors with Telnet. You can do backdoors with all kinds of different cool things that you can do. Like right here, this is a simple Python web server, Python 3. We're going to use a module, HTTP server listening on port 8080. Find LSUID for privilege escalation. Find all cron jobs. Basic port scan. Using dev TCP, like this is crazy. So I'm going to share this with you all so you can look on it. There you go. So there's a bunch of them. This is just one of those that has been around. Now, this particular backdoor was created by Chris Brennan and Bill Stearns and oh God, I forgot the third guy's name, but they were all at Dartmouth when they came up with this particular backdoor. So I've got this backdoor copied and pasted over. I'm going to run it there. And then I'm going to get my IP address, like so, and then we're going to connect to it. So we're going to do netcat, once again, fully understanding that my IP address will be different. Mine at the ETH0 is 10.10.112.203. I make a connection and nothing happens. Nothing happens at all. You're not going to get a pat on the head. You're not going to say congratulations. You've made your connection to your first netcat backdoor. You're not going to get any of that. It's just nothing, just like that. So you have to type something, and now you can see that my backpipe is working. All right, so I've compromised the computer system in kind of a contrived fashion. I have my connection over there, and now it's time to go hunting. And one of the first things I'm going to do is become root. Anytime you're doing threat hunting on a system, it is always a good idea to become root because you're going to be running a lot of commands with a lot of power, like LSOF. Now, I mentioned once again yesterday and this morning that everything in Linux and Unix is a file. And if I were to run LSOF by itself, that's a lot of freaking data, right? That's every open file on the entire computer system, which is arguably a lot. But one of the cool things about LSOF is we can tune that down to get just to the open internet connections. So if I take that LSOF command and I add an I to it, I do that. Now it's just the open internet connections. Now, the problem I have at this point with the open internet connections is it's trying to be too cute by half. It's trying to guess what the ports are. Like, it's like, oh, it's SSH. Oh, it's X11. Oh, it's 5901 with VNC. Oh, it's listening on port 2222. I personally do not like that. So to get rid of that, I add a TAC or a little dash, capital P. There we go. Now I'm just getting the straight raw ports on this particular computer system. Now, the one that's of interest to me, and we'll talk about this more when we get to the Windows section next, the ones that are the most interesting to me are the ones that are established connections, right? So you can see here we have an established connection right here. With this Kali service that's listening on port 2222. And the reason why I really like looking at Kali, like in not just Kali, but any established connections, is it allows me to kind of focus my network, my threat hunting to network connections. What are the open network connections on this particular computer system at the time that I'm doing a threat hunt? The other reason why I like to do this is a lot better than trying to do PSAUX and trying to go through and try to find some kind of evil. There's a lot going on with the processes. However, if I just do LSOF, it's a much smaller universe for me to do network threat hunting. So we've got DH client. It's not really listening. It's just the client. We have SSH as a service, which makes sense because I'm on that service, right? We're listening for container services. We use Docker and all kinds of things. VNC is a full GUI environment on the Kali system, and you can access that by going, well, I guess you can't. You'd have to do SSH port forwarding, but you could use VNC to connect to it as well. We have SSH daemons. Once again, that's just my established session, but the one that's weird is this guy, right? This guy's listening on port 2222 to anybody, and I have an established connection. So what I want to do is drill in on that specific process. So I can do LSOF again, but this time I changed the switches. So now I'm going to put in a P because I want to look at all of the open files associated with the process, and I have the process ID is 3159. That's the one that's listening and it's serving up and it's an established connection. And it says that its current working directory is out of the root. Its root directory. Now this tells me that it's not char rooted. It's actually thinks that the root is the actual root of the system. That's just a little thing. The text, which is the actual executable, is executing from user bin netcat, and then we have these libraries. Right? Now, sometimes you can get lucky and you can do man pages for these. So I can do like man libc, and here is the libc. This is the standard C libraries on a Linux computer system. It's commonly used for a shorthand for the standard C library for standard functions, can be used by all C programs. So, all right, pretty cool. What are the other ones? Let's dig in a little bit more. Let's do libmd. Like that. No man page for libmd. That's fine. What about libresolve? Let's try that one. See what we got. Let's do this. Nope, no man entry for that. Let's try libbsd. Oops, that's not going to work. Nope, nothing for that. And I can check these libraries here. There we go. No manual entry for that. But I did get one for the man libc. So that's telling me a little bit about what this thing does. It's basically a C program, and it's kind of the standard C libraries. Sometimes you can run some of these, especially whenever there's encryption that's being used and it's using third-party libraries, like the actual built-in ones in the operating system for connections. I can see that it's a FIFO pipe. That's kind of crazy. That's our first in, first out, and it identifies that file as a FIFO device file, first in, first out file there. And it also says that it's running PTS. So what is that? If you're looking at a Linux computer system and you see dev PTS, I told you that everything in Linux and Unix is a file. Turns out that is a very special file that is a teletype terminal. So if I do TTY, you can see that I'm running on dev PTS 4. Right? So whenever I'm typing and doing hackery type things on a command line, I'm in a pseudo teletype terminal. And that's what you're seeing there. So if I'm running that LSOF command, I know it has built-in core libraries of Linux and Unix. I know that it has a teletype terminal associated with it, and I also have these TCP/IP-v4 files. It's listening on port 2222. So if we're trying to tie this together, I've got a listener on port 2222. It has built-in C libraries that exist on the system. It has a pseudo teletype terminal that exists on the system. It's kind of giving me a lot of information about this particular backdoor. So we have a question. Would you then search for those libraries on the web, or is it not worth doing? You totally could. If I wasn't doing it in a class, I would probably do some more research as far as what those libraries are. Throw them even to like ChatGPT, right? Like we could just do the whole screenshot thing. Like, what are these libraries, right? And let's try that real quick. What are these libraries? Oops. Hit the caps lock. There we go. And then we just paste it in, send it up. Now it's going to come down and it's going to tell me what each of those libraries do. Maybe we reached the end of ChatGPT. I don't think so. I think it's going to come back. These are pretty well-known libraries. Simple little Google search would do it. All right, there you go. Those are dynamic libraries running as they're loaded. There we go. There's the C runtime library. The dynamic loader is loading shared libraries at a program start, resolving symbols and sending control to main. And then DNS functions for libresolve. So that's basically kind of really nice because that feeds into our theory that this has TCP/IP functionality on it as well. libsd, BSD, strings, buffer, string copy, string cat compatibility wrappers. It's fine. libmd is a hash helper using hashes and checksums. So that broke down what those things do. So great. It's awesome. So it's giving me an idea of what that program does. And by the way, this same methodology is going to be applied a little bit later whenever we start working with Windows and we start running task list /m, where we're going to list out the modules and the dynamic link libraries associated with that executable. So now the other thing I can do is I can cd into proc, then that process ID, and I can type ls, and I can see that I have a number of files here, but the one that I'm most interested in is the executable, the exe. So what I can do on that is I can run strings, do strings against the executable, and it's going to show me all of the human readable printable strings that exist in this program in memory. Right? So this thing is on the hard drive, but the attacker could totally delete it and it would still exist in memory and it would still run. But we want to figure out what this thing is, even if we don't know what the file is. Now, we could use Ghidra. We could do some reverse engineering using Ghidra. We could use IDA Pro. We could use a number of different tools to navigate this particular executable. Me personally, I'm a huge fan of just firing up strings and looking at the human readable strings that I can see inside of an executable. So you can see we have a bunch of things. We see that string copy function right there. String dump, these are all from the libraries that we imported on it. We got sleep, we've got sflag password. Here we have a bunch of format strings. We're moving data in. We got the glibc libraries. We just talked about that. Keep going. This kind of looks like garbage. Now we're getting into errors. Some of the errors that are given to you can be like, these aren't errors like it made a mistake. These are the errors the program could give you. Absolutely. They're in memory. So this is a program and it has a bunch of errors that it can feed you. Like if I tried to connect to something and it couldn't, I could get an error that says create unit socket failed. Unit socket connect abandoned and failed. Poll failed and so on, right? Port number, string, those are format strings. So I can keep going and I'm seeing some more functionality, right? We know that we have TCP receive buffer size, send buffer size, set IPTTL value, very much networky type things in it. But then we get right here and our executable says this is OpenBSD netcat, usage information, and all the stuff that it can do. Right? Now, if you're researching, and if you look at a lot of the articles that come from people that reverse engineer malware, it's very funny. They go through and they show you all the assembly and things like that. And 9 times out of 10, when I'm reverse engineering malware, you will see the usage information, printable strings, and things like that inside of the executable in memory as well. So very, very, very cool. Is it common for admins to use LDD path to binary and create hashes of object for asset management? It is very common to use some type of hashing. And there are a number of different hashing utilities that you can use. Anytime you're doing forensics, though, you would probably do it in mass. And for this situation, if I was researching this executable, I probably would throw it up into something like VirusTotal to do quick analysis on it as well. All right, so that is our Linux lab, which is a really nice kind of starting point for getting into Windows endpoint analysis. So now we already played with Linux. Now we're going to do really bad things to a Windows computer system. So in this section, we're going to go through some of the core live forensics commands, very similar to what we did in Linux, kind of looking at it as a Rosetta Stone. We'll be going through and doing a lot of the same methodology, but we're doing that methodology on a Windows system instead, which is kind of cool. But we will be starting with network connections because that's the best place to start, to be honest with you. All right, so we start with network connections. When we're looking at network connections, there's a lot of commands that answer the question of what is this computer talking to or is talking with it. But there's different commands that answer these questions in very specific ways. We can use the netstat command. Netstat NAOB is going to be the one that we're going to see here in a little bit. all processes. We're going to see the ones that have we're actually going to see the dynamic link libraries and the process IDs associated with them. And if it's an executable, we'll be able to see what that executable is. So NetStat's really powerful. NetView allows us to see shares, and NetUse and NetSession allows us to see the SMB connections coming and going between the two computer systems as well. Josh, just kind of giving you a heads up, one of the things, we do power through. We do labs and breaks at the top of the hour, so that's what we're shooting for. And the recording of yesterday's session is over in resources. So don't worry if you missed out, we got you covered, dude. All right, so let's jump in. NetView. One of the things that a lot of attackers do is they start by compromising a single computer system, and then they will open a share on that computer system. And one of the reasons why they do that share on the compromised computer system is because they're going to compromise other computers and they need to exfiltrate files. So they'll use one computer system as a staging host to pull those files down, RAR them up, and then exfiltrate them out of the network. So one of the things we want to look at sometimes, not all the time, but we want to look and see if they're creating shares, is using NetView to see the shares on that computer system. And this gets into a core question. Anytime you're working with these different programs and you're doing threat hunting, what shares should be on your computer systems? I kind of recommend people do threat hunting before they get into an incident situation. So they have an idea, one, they're practicing. This lab and this class is great for practicing, but it's also really important to kind of exercise these skills to baseline what is normal on your computer systems. Now, NetSession. Let's say, hypothetically, we detected malware on system Y. Okay, and we start investigating system Y, what's going on system Y, but we can fall into a trap in believing that the malware and the entirety of the incident only exists on system Y, and that would be a mistake because we may have detected that malware on system Y, but it could be that system Y was compromised from system X. And system Y may also be compromising system Z. It's kind of like a computer centipede with multiple computer systems connected to each other, right? So if we want to, we can say, who is talking with the system currently? Like who has an open connection with me? And if we're Y, we will see that connection coming in from system X. So we can't think of incidents and malware as just one isolated computer system. We have to investigate how these computer systems are interrelated and how they're communicating with each other as well. Now, the inverse of that is NetUse. NetUse is who are we talking to? So we may be compromised from X to Y. We can run NetSession to see that. But NetUse can see who we are talking to, right? You know, you pay your debt to karma, you party for a living. What you take can't kill you, but be careful what you're giving, right? What is Y connected to? And for that, in NetUse, we can see that outbound connection from Y to Z. Once again, kind of the opposite of NetSession. Now, the big one that we're going to use is NetStat, right? So let me close out these Kali Linux terminals and let's get a Windows terminal up and running. There we go. I'm just going to open up a standard command prompt and I'm just going to run NetStat. Right? NetStat by itself, no big whoop, not a lot going on, but we're not getting a lot from NetStat. Like we're getting what is the protocol, the local address, the foreign address, and we're also getting the overall status. Do we have it established? Is it time wait? What is going on with that? So not really the greatest, right? This is kind of in that area of somebody sitting at a computer system when they think it's compromised and they hit Control Alt Delete and they look at the processes, right? It's like, what the hell are you looking for? You've got to be able to put in the right switches to be able to get the right data. So if we're looking at NetStat, we can take this NetStat and we can do amazing things with it, right? So we can run NetStat minus NAOB and look how it changes. Like it just explodes with wonderful, wonderful data, right? So the first one at the top, we have a process ID 844 and it's 135. If you look, Let me try to make this a little bit bigger. Let's do this. Let me run that. That's just how it's going to be. If we look at that first process, right, that's our RPC service, right? Remote procedure call. Now, once again, I'm not, this class is a 2-day class, right? But you would definitely want to spend some time learning what the core services are on a Windows computer system. Once again, baselining and having a better understanding of what is normal on that computer system. But RPC is really quite normal, remote procedure call. The next one is we got SVC host is the executable that started it. But we also have this one right here, 445, process ID 4. It says cannot obtain ownership information. Now, yesterday we looked that up. Do you guys remember? What did that mean? When we have these process IDs of 4 and it says, hey, cannot obtain ownership information. Remember I ran that? What did that mean? I don't know if we have anybody typing in. If you remember, the system process, we always get that. It's not necessarily hidden, but the system process, it's process ID 4 on every Windows computer system, and it's always going to say cannot obtain ownership information. Now, why is that important to understand? It's important to understand that because if you ever testify in court and you have theories, it's good to test and validate those theories before you get into court. The other thing that's really, really powerful is looking a little bit deeper into all of the different things that a cross-examining attorney may ask you. So if you're ever going to testify in court, it is really helpful to go through and look at these things and say, if I was a cross-examining attorney and I just wanted to be an a-hole, what would be questions I would ask? And that cannot obtain ownership information is definitely one of those questions I would ask. But by and large, we have what is the process, what is the executable, and what is the service associated with it. So very, very powerful series of commands that you can do. So that's netstat and AOB. Netstat minus F, I really wish it worked better. If I do netstat minus F, it's supposed to go through and automatically do DNS lookups for all the IP addresses. And in this situation, it actually did a pretty good job. We have these systems. Oh, this is all my system. This is all my host name. But if I open up a browser, let's go ahead and open up one now. There we go. And then I rerun it. You're going to see that it changes dramatically just by opening up one browser session. Give it a few moments. There we go. And it's going to try really hard, right? You're going to see that we have Nginx load balancer. We have deploy static Akamai technologies. It's all stuff that you would expect, but you're still going to have a whole bunch of just raw IP address connections, which is kind of a little bit annoying. And it also kind of complicates what's going on the system, right? So I'm going to go ahead and close that out, and then you can see how it's very different. CLS, there we go. And then you're going to see how that really reduces the amount of stuff that we have to investigate. And truly, this is what makes incident response really hard, is trying to sift through all of the cruft and crap that you would normally have with a browser. I'm trying to look at it. All right. Windows processes. So we start by looking at networking, like what are the network connections? And then from those network connections, based on the established, related, SYN sent, or closed connections, those are the three you want to focus on. Established, wait, SYN sent, and closed, right? We want to see those connections because those are active connections. And usually the malware that we deal with is going to be outbound connections, what is leaving from this computer system. So we're going to kind of focus on those established connections. Once we have some established connections, we get an idea of what they are, we can start digging a little bit deeper into suspect processes. So let me open up this browser again and reestablish a bunch of cruft and garbage. And now I can do netstat minus NAOB. And it's going to tell me what are the processes that are making the established connections. So I have a bunch of Elastic Agent connections that are trying to go out, but I also have a bunch of Microsoft Edge connections. That's my browser. So a lot of those IP addresses that we saw with netstat minus F is just Microsoft Edge doing Microsoft Edge things, right? Now, I wouldn't necessarily start by digging through Microsoft Edge, even though you absolutely can have malware that can be using Microsoft Edge. We definitely see malware that does that, but I would look at the other established connections before I start looking at the Microsoft Edge connections on that as well. All right. All right. My update is complete. That makes me feel warm and fuzzy. All right. So now let's figure out what we can do with processes. So I mentioned Control Alt Delete, where people that are trying to figure out if their computer system is compromised, they'll hit Control Alt Delete and they get something like this, a new task list. And this is what they got. And I don't know. It seems to me like this isn't the best use of one's time. A little bit frustrating there, right? This also kind of brings up a question. What do you think would be a good name for your malware? Like if you're going to have malware execute on your computer, what would be a really good name for your malware? Just something's right on the tip of my tongue. Yeah, SVC host. All right. Now, the problem with this is I have like dozens and dozens and dozens of SVC host free money, right? That's a good one. Tons of SVC hosts running on this computer system. And that is services controller host. Now, that is the process that starts various services. So what I can do is I can start taking that task list command and I can start tweaking it, right? So I can take task list and do space/SVC. Now I'm seeing what those SVC hosts do, right? So this SVC host with a process ID of 1788, that's my DNS cache service that started up. Network performance monitor is 2024. Spooler service is 2508 and so on, right? So we're getting an understanding of like there's lots of services that start from SVC host. Now, I'm going to be completely honest with you. I think that this is no way to create an operating system. Like I don't know why they did this. Like that's just nuts. But that's the way they did it, right? SVC host starts the services and it all ties back to services controller host. So it becomes really important for us to be able to investigate and differentiate those various services controller hosts from each other. So there it is. The next one is task list /m. Let's go ahead and do that. So I'm going to take task list /SVC and I'm going to replace it with M. At this point, it's going to show us all of the dynamic link libraries that are loaded into every single process. This is very similar to what we did with LSOF space minus lowercase, lowercase I space capital P. We find a process ID, then we do LSOF space TAC lowercase p, then the process ID to see the modules that are loaded. We can do that here, right? So now it's showing us all of the dynamic link libraries that make up every single executable. And here in a little bit in this lab, you're going to see some consistencies in what dynamic link libraries are loaded up into some malware. Not all, but some malware in just a bit. So if I want to flip that, let's say I've got a dynamic link library, like you guys are coming up with some really cool names like employee salaries, totally harmless.exe, secret certificate process, elite hacker trojan.exe. I like Roswell's AWS recovery service. That's a good one, right? Let's say we have a dynamic link library named something like that, right? I can take this and I can flip it on its ear. So I can do task list space /m and give it a dynamic link library like ntdll.dll. And now it's going to show me every dynamic link library, or sorry, every service that is using that dynamic link library, which is kind of a cool flippy. Now, if you have a specific process that you want to investigate, doing this just generates a lot of noise, right? If you want to kind of tone that to the point where you're just looking at a specific process, you can do that with task list space /m, fi for filter, process ID equals the process ID in question as well. WMIC still works on many Windows computer systems, but it is being deprecated. I'm sure you can still do all the stuff with PowerShell, so we'll be updating this class in the near future, but WMIC does still work. It stands for Windows Management Instrumentation Command. So there we go. I can get the process hierarchy, like what process begat which other process, what is the process ID, and what is the parent process ID. And then finally, I can get the command line invocation, right? This gets really helpful, especially if you look at like what are the command line parameters for various executables and how that actually works as well. All right, so now we have a lab with the Windows command line where you're going to get an opportunity to infect your Windows computer system and then do an investigation of that infection for your Windows computer system. So I'm going to go back to my lab directory and we're going to go to Windows command line. I did not want to see that. There we go. All right, Windows command line. Now, in this lab, we're going to generate some malware from scratch. We're going to run it, and then we're going to use tools that we just talked about to actually hunt that malware down, right? So how would you identify that malware? So you're going to open up a Kali prompt, and then you're going to have it running set up so you're ready to go. Then you're going to make sure Windows Defender is disabled. You're going to open up a PowerShell command prompt, and then you're going to set the M preferences disable real-time monitoring equal to true. All right. If you get any errors that are red, it's okay. Then we're going to make sure the firewall is off. Okay. At this point, a quick note. Just a quick note. I know it's lame that we're shutting off the firewall, and we're also changing the administrator password. The goal of this lab is not how you hack a Windows computer system. The goal of this lab is how do you identify malware on a Windows computer system? So we're doing the most expedient thing to infect your Windows system. Just kind of setting that out there. But I've got something I'm going to show you real quick. You see this right here, the net user administrator, and we're setting the password to password 1234. I want to show you what happens here, right? So I'm going to do that command, and I've just changed the administrator password. Now, you want to be very careful from this point on that you do not refresh your browser session for your Windows system, and you don't close and reopen your tab. The reason why is because Guacamole uses the default password, the generated password, to access the system. It's already logged in, everything's fine. But sometimes students get this. I'm going to refresh the session and show you the problem. They do this, and then they're going to get an angry red bar. Bam. And this means that Guacamole, with the default password that it was using to generate that authentication, password is changed. If you get this angry bar, one of the things you need to do is go back and destroy your lab and then restart it. And then you'll have to start the lab over again, which is kind of a bummer. So the key is do not refresh your tab. Do not close your tab. It's like Happy Fun Ball. Do not taunt your tab. Do not look at your tab in a funny sort of way. It's a bad idea. So there we go. Although it looks like my lab destruction is not. Oh, I know what's going on. I got to re-authenticate. There we go. There we go. So now I'm going to destroy the lab. There we go. That's better. And then after it's done destroying, I'm going to restart it. So once again, be very careful. Do not refresh your Guacamole session. All right. So we're going to go through, we're going to disable the firewall, which is weird because disabling the firewall actually is the most realistic thing that we're doing as far as compromising. Why is that? In most environments that are running Active Directory, the Windows firewalls are off. So when we gain access to an environment post-exploitation and we start laterally moving, it's very rare for an organization to have their host-based firewalls enabled. So we're going to shut that off, right? So we set that password to administrator 1234. We run ifconfig. You can use that password, but you have to remember it for later. I have students that set it to supercalifragilisticexpialidocious, even though the sound of it is somewhat quite atrocious, ! 1 and they forget their password. Don't do that. Once again, if that happens, you're going to have to blow it away and start over. All right. You're going to get your IP address of your Windows computer system. Your IP address will be different, and it'll be different than your ADHD Linux system as well. Now go back to your Kali terminal. We become root. We start MSF console, and then we're going to use exploit Windows SMB PS exec. on that system. Then we're going to set the payload to Windows Meterpreter reverse TCP, set the R host to be 1010 1 dot whatever your IP address is. Your IP address will be different for your Windows computer system. Setting the password for SMB user to administrator, and the password is password 1234. If you changed it, remember you changed it. Then we're going to type exploit. Now we've compromised our Windows system. Now it's time to go hunting. The first thing we're going to do is we're going to start with those network connections, right? We'll start with the network connections. Netstat NAOB to start that hunting, looking for that established connection to our Kali system. There it is. Then we can see netstat minus F. Is it resolving? No, it doesn't. It's a raw IP connection on that. Then we're going to do tasklist space forward slash M space forward slash FI. We're going to PID equals the process ID to hunt that process ID down. Then we're going to do WMIC to get the parent process ID for it. And that's the lab. So that's your introduction to hunting for malware on a Windows computer system. All right, so this lab is going to take us up to and through the break. It's 11 o'clock Mountain Time. This is going to take us 30 minutes. We got 20 minutes for the lab, another 10 for taking a break and something to drink, and then we're going to resume. And then I'm going to walk through this slowly and give you guys kind of a breakdown of what is going on. I might even do some fun off-roading activities as well. So let's start the clock. Let's get rolling, everyone. See you in 30 minutes. All right, here we go. All right, so I had to give it a few seconds. I went around and I was vacuuming up flies, and I forgot to power on my VMs for this session. So that's why we got an extra minute on the lab. No, PowerShell is magic, Lift Plus. I would just say PowerShell is pretty magical. All right, so, and you got to understand, what was life like before PowerShell even existed? We were just stuck with the Windows command line. Those were dark, dark times, dark, dark places that we had to go. All right, so let's get to it. All right, so I have my VM started. I'm going to start up that VM and I'm going to connect to it. There we go. And the first thing we're going to do is we're going to open up a couple of terminals. The first one is going to be a Kali terminal, and the next one's going to be a PowerShell terminal for us to set and configure the lab appropriately on how this would go. Let me think. Let me think. I'm going to share with you guys a lab that I just created a little while ago for a class that I was teaching a couple of weeks ago, last week. I don't know. Everything just kind of blends together, don't it? So I'm going to start up the Kali terminal, and I'm going to start up a PowerShell terminal. We're going to accept that little warning. I'm going to take a couple of minutes, and I'm going to change the settings. We're going to change the appearance, change that font. While we're waiting on the font, we're going to start PowerShell, PowerShell. And we're going to make it bold, 16. There we go. All righty, there we go. All right, we're looking good. So the first thing we're going to do, kill that AV. Once again, the goal of this lab is not to bypass antivirus. If you want a class like that, you should, did I screen share? Resume. There we go. We're back. We're back. We're back. All right, all I have is 2 prompts. That's all I've opened. So we should be back in business. Let me drop this down so I can see. There we go. And I disabled the AV. Once again, if you want a class on bypassing antivirus, I would strongly encourage you to look at Joff Thayer's course for implant creation. Next, we're going to kill that firewall, just because that's the way Active Directory environments are. Just no firewalls, just YOLO sec all the way through. Then we're going to set the administrator password to password 1234. And we're going to get our Windows IP address. And then I'm going to scooch this over here to the left, so I have that IP address handy dandy and ready to go. Become root in our Kali system, like so. There we go. And then we're going to run MSF console. Now, MSF console takes a moment to start because it is the world's largest Ruby environment. And what we mean by that is there's a lot of stuff going on under the hood. It's starting a lot of different libraries and things to get it to go. That's good. Not low sodium V8, but I got to slow down on that. You know, I'm doing Spindrift Blood Orange Tangerine for my drink of the moment. And then once we get in, we're going to use this exploit that actually isn't an exploit at all. It is um, it is quite simply using PSExec to remotely authenticate and start a service. And PSExec was created by Microsoft, a guy by the name of Mark Krasanovich, who created sysinternals. So PSExec is literally using built-in functionality in Windows so we can remotely access a system. Now, this is weird because this is the most heavily used exploit in air quotes, in the Metasploit framework because it works. If you have credentials, you have hashes, you have any of those things, you can absolutely use this to gain access to remote systems. So we're still waiting on MSF Council. There we go. We use exploit Windows PSExec. We're going to set the payload to be Windows Meterpreter reverse TCP, like that, because we want that connection to come back. We're going to set the R host or remote host to be our Windows system, which is 10.10.74.159, like that. Then we're going to set the SMB user to be administrator. And then we're going to set the SMB password to be password 1234 to successfully compromise said computer system. And then we run exploit. All right. So we run exploit. We log into the system as administrator, password 1234. We generate a service on that particular computer system. It reaches back, grabs our full like service, what we call a stage. We have a stager and a stage. And the stager is kind of like the beachhead. And then the stage is where it pulls back the rest of the malware. And we have a compromised Windows computer system at this point. All right. So life is good for the hackers. Now we're going to turn our hat around and we're going to focus on a defender's perspective. How does a defender deal with this? So the first thing we're going to do is what I said to start with. We're going to start by looking at those network connections on this computer system. We're going to start by looking at the network connections. We're going to run NAOB. We're going to see all of the network connections, including TCP, IP, and UDP. And we want to see the process ID, and we want to see the coordinating dynamic link library or executable. So I'm looking specifically for the established connections. So we have a listening. We have terminal service, which we totally expect, PuTTY, which we totally expect. But then we get to this PowerShell service. All right, so that PowerShell service is kind of a bit weird, right? So we want to investigate that process ID of 3712. So what I'm going to do is I'm going to take Notepad, and we're going to start up Notepad. All right. And I'm going to copy and paste this whole thing right here. I'm just going to copy and paste it just so I have some level of notes on what we are doing, right? So this is the process ID of interest, 3712 for this system. All righty, now we're going to run netstat minus F. And the only thing I'm really trying to do is show here that that connection to port 4444 isn't going to show up as a resolved connection. So it's not going to have a host name. Now, it totally could in the real world, just kind of showing you in this situation that it does not. So we got the foreign address, and what do we have right here is where our malware is. So that is the suspect. Kali Linux IP address for it. Then we're going to look at the dynamic link libraries associated with this. Copy that one. There we go. Oh, I got to put in the process ID. Doop, doop, doo. Making mistakes. So it's 3712, 3712. We do that. Now, this is going to be a bit strange, right? So we have these dynamic link libraries. We have the ntdll.dll library, the wow64 base. What are those wow dynamic link libraries? What is that? When we say wow, whoa, what do we have going on there? What does that mean? Wow. Yep, that is Windows on Windows, 32-bit and 64-bit compatibility. So that's what those dynamic link libraries mean. Now we can go a little bit further, right? So I can go command prompt. Let's go ahead and start up another command prompt running it as administrator. And I can CD into the intro labs directory and I can do netcat listen on port 2222. When someone connects, we're going to execute cmd.exe. Now we got a netcat listener. And I can actually connect to that netcat listener from our Kali system. Just open up another Kali prompt and I'll go netcat to 10.10.74.159 on port 2222. And I get a command prompt on that system. At least I should have. Oh, that's weird. Did I not run it? Pretty sure I did. Oh, my ports are weird. Hold on, let me kill that. I got too many twos. There we go. That looks better. All right, so now let's connect. Now we got a command prompt. All right, so let's do that exact same thing we just did with our Metasploit PowerShell payload. And let's hunt down our netcat listener and see how it's any different. So I'm going to run that netstat minus NAOB or NAOB. And we've got, we found our 4444 already. We're looking for that 2222. Where is it? Did I miss it? This happens to me all the time when I'm trying to find these things. It's got to be there. It's going to be established. And that's putty, SVC host, PowerShell. There it is right here. So we've got this one. It's 128 is the PID. So I'm going to put that PID into, let's actually just grab that whole line, right? So let's grab that whole line, copy it, and I'm going to paste it down here like so. There we go. So now let's do that same hunt. Right. So we did task list. We're going to run that one. That's our Metasploit payload. That's our PowerShell. And then we're going to put in, what is it, 128 as our netcat. And oh my gosh, it's almost the exact same dynamic link libraries. In fact, it's the exact same dynamic link libraries. Now, I'm not saying that every time you get this direct configuration of dynamic link libraries that you have malware. But the thing that you need to know is Netcat is the most fundamental, basic backdoor that can be created. It was created in raw assembly by the Hobbit a long time ago. I want to say in 96. Might have been 98. I'm not sure. And another member of Loft Heavy Industries Group, who I can't remember their name, is the one that converted it over to Windows. But it's very, very, very basic. So what you're seeing here is the absolute core basic dynamic link libraries to allow a backdoor to actually run properly. All right, so now we're going to do WMIC where process equals. We're going to get that command line. I'm going to put in, let's put in the netcat process ID first. Let's do 128 like that. There we go. We can see our netcat execution. Nothing crazy, nothing weird, just straight up. No kill, all kills, no thrills. And now we're going to switch it over to our dynamic link library listing. We're going to pull the process ID 3712. That's our Metasploit one. Watch this. Bam. Oh my gosh. That is your obfuscated PowerShell. Quick. Let's go to ChatGPT. See if ChatGPT can decode this. Should we give it a shot? See how good ChatGPT does on this. I'm just giving it a screenshot because I'm mean, right? We're waiting for the screenshot to upload. Let's see how it does it. If anything, I use ChatGPT for two things. One, OCR. I would just refuse to decode it. The other thing I do is I talk to ChatGPT and create articles. I'm like, ChatGPT, take the following text and convert it into an article that's suitable for a LinkedIn newsletter. And then I just talk to my computer. That's nice. Here we go. It's giving us a breakdown of what the structure of the script actually does. Not bad. Not bad. Pretty cool. It's trying to disable AMSI, the anti-malware service. It's in a decoded blob. And it's like, if you want to do this safely and offline, you can decode it on the base 64 init stuff without executing it. And here is the code for doing that. Isn't that cool? Right? I mean, ChatGPT is incredibly powerful. AI is incredibly powerful, but we have to get it to this point, right? We have to get it to this point. We can't be in a situation where we can just throw random crap at it and expect that it's going to be able to pull down everything all the way through. So very, very powerful tool to use, but it really helps to understand kind of the underpinnings of it as well. ChatGPT told me to get good, noob. That would be pretty funny. There we go. All right. So I'm going to destroy my lab, and I recommend you destroy your lab too. Because remember, as soon as we refresh, it's going to be broken. It's going to be broken because we changed that administrator password. So I'm going to destroy the lab. Give it a few seconds. Oh, I love that meme, haircut fish. The Hulk smash computer one. That's awesome, right? So we're destroying the lab right now. I'm going to give it a few moments and then I'll come back and we will reestablish it here in just a little bit. All right, so we have other tools that we can use, right? That kind of like quick triage tools. One of the tools is Deep Blue CLI, and the other one is Hayabusa, which we'll probably talk about a little bit later, depending on how our time goes tomorrow. But we have another lab for it. Oh, by the way, I did promise you something, and I completely forgot about it. Let me pull this up over here. There we go. I forgot about it, and I apologize. I apologize. I'm fallible for sure. There is a lab right here that I just created. Let me go all the way down to the bottom, to the bottom, to the lab directory. I have password spray right here, and I have external password spray. I created a lab that walks through if you were to try to do an external password spray. It is a technique that's used by a number of different APT threat actors. How would you gain access to the computer system? So we pull down a script to generate 200 users, and then you use a different script that you have users, and then you use Metasploit to do a password spray, find an administrator account, and then authenticate as that administrator account. Let me throw that in real quick for you all. It's another cool little lab that I just created that we're incorporating into some more fun stuff. So you can play with this one too. All right, so there you have it. I also should be able to restart my VMs, still destroying. It turns out it takes a little while to destroy and restart those labs. It takes just a little bit. So what we're talking about now is we're kind of getting into what are the tools that we have that we can do analysis on event logs. And we have two tools. One of those tools is Deep Blue CLI. That's the lab we're going to do next. And then we also have a lab utilizing a tool called Hayabusa. Like I said, if we have more time, we will jump that. And by the way, this is like the first like full class where I'm getting you access to a completely different virtual machine. It's our network threat hunting VM that has Rita and Hayabusa and Saracata and a bunch of cool things built into it because we're building up a new network threat hunting lab here at Anti-Siphon as well. We did get a question from Black Sheep Mamba. How long do you have access to the labs once the class is over? As long as they're running, I guess. And if you burn all of your hours, if you burn through 16 hours, you can always add more. And they're pretty cheap to get like a whole bunch of hours with it as well. Will there be a new version of ADHD? Probably not. I'm probably going to be sticking with just using Cloud Labs in flying in the face of what happened yesterday, right? Amazon went down for a few hours. That was kind of a big deal for a lot of people. But for me and even this class, the ability for people to have full virtualized labs in their browser, very nice, very nice. All right, so now we're moving into Deep Blue CLI. Let's say that you're a SOC analyst and you have an organization that you believe has a compromise, and you can get event logs from that organization. And it's relatively easy for people to get set up and get, to pull event logs off of potentially compromised domain controllers and individual workstations. Then what do? You just open up the event logs and go through them one at a time? Or do you have some automated tools that can make that entire process a lot easier for everyone involved in trying to do the analysis? And we're going to fall into the latter. We're going to be looking at what are the cool tools that we have that allow us to do this easier. So this is what Deep Blue CLI looks like, and it comes with some really cool kind of sample event logs that you can play with that are pretty neat. So we're going to look at password guessing. That's where someone is trying to log in with one user from one workstation trying to log into an administrator account, right? They're going to try to guess that password. We can also do a deeper dive using PowerShell because people were talking about earlier how PowerShell is magic, and I'm inclined to agree. And we can actually pull out those event logs and do specific searches in them as well. There we go. This is a little filter that I wrote up, just having fun with it. So showing you can do it. And Deep Blue CLI also has Deep White CLI, where it has the capability to actually take the hashes from sysmon logs, and then it can check those hashes with VirusTotal as well. So that brings us to Deep Blue CLI. So let's go ahead and let's flip on over here. It still says it's destroying my VM. Let me try starting it. Please wait for them to destroy. Okay. So I have other labs that I can do here as well. Does anybody else have it stuck on destroying? Or is it just me? Yeah, if I refresh it. All right. You're stuck destroying? Okay. Yeah, it's been a while. Hold on. Oh, worked. I guess I just needed to be patient. So I'm going to start it back up. There we go. We're kicking it off. All right. Just took a couple of seconds. All right. So don't know. It's just like knew I was going to call Roman, and it's like, I don't want to mess with that guy. Roman scares me. AWS knows what's up. It does. All right. So what we're going to do is I'm going to go back to the lab directory, and we are going to do the Deep Blue CLI lab. All right, so in this particular lab, what we're going to do is just take event logs that are previously compromised event logs, and then we're going to do analysis on those event logs, looking at a number of different attacks that tend to show up. So we CD into intro labs, we run Deep Blue CLI master, we set the execution policy to be unrestricted, very common for PowerShell scripts, and then we're going to run it against new user security. And I recommend throwing this into ChatGPT and asking ChatGPT what it thinks is going on here. Because there's some shenanigans going on in this particular output. Then we're going to look at a password guess on the system. Somebody's trying to log into the administrator account. Then we're going to do a password spray. Now, a password spray is a fundamentally different critter than a password guess. With a password spray, we're taking a single password and we're attempting to log into multiple different accounts. With a password guess, we're trying to guess the password for an account. So they're two different things. Then we're going to look for PowerShell obfuscation. Now, if you remember in that last lab, which I just so happened to have the breakdown from ChatGPT, ChatGPT gave us a breakdown of what type of obfuscation was being used for that PowerShell being uploaded from Metasploit. We're going to show you a bunch more of the different types of obfuscation techniques. And what I want you to do is ask ChatGPT what it thinks the obfuscation techniques are. And none of them at all are normal. Like we got weird camel case, we got base 64 encoding, we have some binary encoding, we got character array obfuscation. We also have some that's just really weird pluses, minuses, and that's kind of strange. I wonder what that is all about. All right. So that is the lab. Now we're going to put 20 minutes on the clock. So we're going to have 10 minutes for the lab, probably 15 minutes for the lab, and then 10 minutes for the break. So we're going to give you a full 20 to jump into this. So with that, let's get rolling. I will see you on the other side. By the way, if you are still getting it took me a long time. So what do we do? How about we put in 30 minutes? Let's put in 30 minutes for this lab, just because we still have some systems that are in the process of being destroyed. It took a while for my system to be destroyed, and my creating machine is slowing down. So let me hit up Roman, see if we can get some more resources, and I'll see you guys on the other side. And then watch the chat. I may increase the time. Right. And we are back. All right. So let's jump in to this lab. It took us a little bit longer. Once again, I think I talked to Roman. There was one of the guacamole instances that was a little bit flaky. So he had to reset that. And then I think everything went pretty okay after that. So lab's pretty straightforward. Let's go ahead and let's get started. So I'm going to open up a PowerShell prompt. And then we're going to CD into the intro labs, because that's where all of our stuff is. We're going to CD into Deep Blue CLI master. And then we're going to set the execution policy to be unrestricted. There we go. I'm just going to go yes to all. There we have it. And then we're going to run the Deep Blue PS1 new user. So whenever we ran this one, what did you guys see that was interesting about this one? Anyone have any takes, hot takes on this? Like, why is this one somewhat interesting? Oh, wow. Wind just kicked up. If anybody's typing, several people are now typing. Yeah, user created and then added to the administrator group, right? So you see that, and then also look at the username, right? So if we look at the username, right, we have a username, we have this dash, and then we have this IE user. Now, here's the trick, right? Whenever you're watching Magic, you never really watch what they're trying to show you. Like if they're showing you this hand, watch this hand, right? So if we're looking at the username, that's interesting, but look at the SID. So you can see that the SID is the same. So we got a user that's created, right? And then immediately added to the administrator group. And that SID is what's more important than the name. Okay. That SID is what's more important than the name. Okay. So that one's kind of neat, right? Next up, let's go ahead and let's do password guessing. This one's pretty straightforward. This is just what it looks like whenever you have somebody trying to brute force an administrator account on a computer. There we go. Takes a couple of moments for it to go through. And it's also interesting, this particular one is going against the administrator account. Now, the administrator account is interesting for a couple of reasons. The first reason the administrator account is interesting is if you're trying to do a password attack, did I just freeze? There it is. If you're trying to do a password attack against most accounts on Windows computer systems, you will log out. Like if you try to do 3,560 logons for an administrator account, you're going to lock that account out and hard, right? However, you generally by default cannot lock out the administrator account for obvious reasons, right? Like you need to have an account that you can come back and you can restore. However, the administrator account generally, unless you make some weird changes like I've made on some of these systems, you can't log in remotely via SMB. You can log in locally at the keyboard or over RDP. So that tells me this is either RDP or this is a local attack on the system for modern systems. Password spray. Let's go ahead and let's do password spray. Now, this one's different. Instead of somebody trying to target a specific account like administrator, they're hitting multiple accounts with a password that's more than likely going to be used. That would be a password like season and year, like winter 2025 would be a good example. So you can see that there's multiple failed login accounts from one workstation with one user ID. This is usually an indication of a password spray account. Then we get to the last one. This one's kind of fun. These are obfuscation techniques. Now, what did ChatGPT tell you guys? You want to share what ChatGPT found on some of these? Because I'm personally curious. Like I can go through a lot of these and I can tell you what's going on. Like the first one, they're doing all kinds of camel case and they're adding in a lot of spaces because they're trying to break that signature on that as well.
Core technique, binary. What do we got? We got binary characters, hex to octal, marshalling, assemble an executable in command, new object, mimikatz is what it's pulling down. Very good. But like looking at that, right? Like looking at that, I think it's interesting how it's actually doing that. It's doing a pretty good job, right? It sold all to get jobs with me, right? That's okay. I wish I could. Like, oh man, if I had an infinite amount of money, oh, you guys could all be my flying monkeys. Just think about how much fun that would be. That's the way to go. So this one we're trying camel case, and we're adding in a number of spaces. This one we're adding in a tremendous large number of spaces at the beginning to try to get outside of the buffer range for it. This one, we're doing a character array where we're taking each character. If you remember, I did the man ASCII thing where we said you can go to man ASCII and like hexadecimal 4-1 is a capital A, 4-2 is a B, and things like that. There's multiple different types of encoding, right? Like you can do octal, you can do epsidac. This is a different type of encoding, and it's using the characters and it's specifying one character at a time and loading it into an array. All right. The next one is just weird obfuscation, just basically a different style of obfuscation. It's kind of in that same realm as binary, but it's like, what the hell? All of this was done with a tool called invoke obfuscation, which is a tool whose sole purpose in life is to do this type of hardcore obfuscation of PowerShell. Character doing the same thing, but instead of doing char 20, char 24, char 5, char 125, it's loading each of the characters up in an array. Base 64 encoding, binary weird encoding in there as well. And then another character array is being used there too. So, all right. So that's kind of cool, right? A number of different ways to try to get around detections on systems as well. That's Deep Blue CLI. All right, so now we're going to talk about server analysis, and this is going to lead us up into a pretty cool lab. We're going to be doing firewall log review because one of the constant things that I love about computer security today is the fact that everything changes so quickly. Like, we like on the news yesterday, we were talking about crowd strikes and things like that, and how if you're just running one product and an EDR, like that's not going to protect you for absolutely everything, right? You've got to look at other different types of things. And you're going to be constantly encountering a wide variety of different servers and applications. Then you're going to have to figure out how to incorporate that into your environment. Had a question, why don't EDRs just decode and then detect? It has a lot to do with how things are actually invoked and where the EDR is placed insofar as the operating system, right? Like some of these things will like do analysis when things hit the disk and come off the disk. Sometimes we can insert things directly into memory. Sometimes you can find certain directories that are bypassed that AMSI doesn't run, like some directories associated with Teams are ignored by AMSI, the anti-malware service. So that's what they're trying to do, right? They're trying to do that decoding and detecting, but that's the cat and mouse game, right? There's all kinds of various ways to decode and encode and then encrypt and use different keys. It's really an exciting and dynamic thing to be an offensive company and an offensive security engineer. So good question. All right, so let's go ahead and let's talk about logs, right? So one of the first things that you're going to do anytime you encounter a new server or service, like let's talk about F5, let's talk about Palo Alto, let's talk about Fortinet, you can talk about any number of vendors, right? That don't fall into the realm of your standard Active Directory event logs or your standard EDR logs that you get off your workstation. You have to find your logs. And this is an example of an Apache log, right? So we have the access log. So you can see we have this %5C, %5C, %5C. That's an attack. It's a directory traversal attack. And %2F is just // different types of encodings again there. But you can see that in that log. Now, one of the things I always tell people is whenever you're doing logs or you're doing analysis, you need to be in a situation where you can test and evaluate that your logging facility and your environment is tuned properly to detect these various attacks. Error logs, right? So we have in Apache, we have an access log and we have an error log, right? We have two separate logs. Now, the access log is literally the access log, and the error log is whenever the web server threw an error, right? And you can see that someone is trying to pull down zip archives or they're trying to pull down different things that just aren't present. And we can look at those errors as well. Authentication logs. This is a standard Linux authentication log. You may be getting logs from Active Directory, but we run into organizations all of the time where they don't have logs for their Linux computer systems because they fell for the trap of like, it's Linux, therefore it must just be secure naturally. And they tend to ignore their Linux environments, right? So this would be an example of this is what the logs look like. And you can see the logs are in the var log directory. So we can pull it down and we can do analysis. But then we get into the question of like, where do you find the logs? Like, if you look at all of the complexity that exists in computer security today, once again, if we start branching out like away from the endpoint, if we start branching out away from Active Directory, gosh, there's a lot of different servers and services, right? We just talked about Apache a couple of seconds ago. But if you look at the CIS benchmarks, like if we go here, let's go to CIS benchmark standards. There are a ton of different things. Like we have Alibaba Cloud, Alma Linux, Amazon Web Servers, Apache Cassandra, HTTP Server, Tomcat, iOS, Bind, DigitalOcean, Docker, F5, right? F5 was in the news pretty heavy, still is, right? So if you want to go through and do an audit of your F5 environment, you could actually look at the benchmark for F5. I'm willing to bet that up until last week, a lot of organizations really didn't even give much thought to their F5 infrastructure. They didn't give much thought in like if it was compromised, how would they actually detect it? Where would the logs be and things of that nature? Google Cloud Compute, what is it? HPE Aruba networking, Cloud Foundations, WebSphere, Z Systems, Juniper, Mint, Exchange, SharePoint, Oracle. Oh my God, it just goes on and on and on. And this is the problem, right? Because if you're working in computer security, you're not just going to be on that EDR and that Active Directory log. You're going to get called in to do log analysis. You're going to get called in to do configuration analysis on something else. So what should you be looking for? Well, we should be looking for key configs for the servers. Like where are the files, the tables? Oops. Go back to full screen. There we go. What are the key configs? Are there files? Are there individual tables? Is there a GUI that we have to go to? What are the key processes? We talked about ping, port, parse. Where does it store user information? Is it in a file? Is it in a table? Is it in a GUI? How do you go about auditing it? And then what are the core ports that are open on the system? These are all things that the CIS benchmarks can answer, right? These are absolutely places that the CIS benchmarks can answer. So use an example, PostgreSQL, right? It may not be what you run at work, and that's fine. It's not even what we're doing in the lab. I'm just giving some diversity from Apache to Postgres to Cisco adaptive security appliances, what's coming up in the lab. But we run into this situation all the time. As an offensive engineer or a defensive engineer, we have something new. How do we audit it? How do we break into it? And these guides are really helpful. So here's a user example. It's giving me kind of, what is the description for ensuring that excessive administrator privileges are revoked? And you can see we can run who am I? I'm running as Postgres. I can log into the Postgres database and I can look at what are the privileges. Now, I expect Postgres to have high level privileges, right? That's the built-in account. We have super user, create role, create DB, replication. And then right below that, it says, now let's inspect the same information for a mock user called app user. And you can look at this app user is clearly an overprivileged user account, which happens all the time in databases for web servers, right? Ports and services. I can find out that it can use SSL when someone connects to it. And the default port is 5432. And that brings us to our lab. So let's say that you're given logs. Like if we go back to these logs right here, how do you parse that? How do you go through those logs and do analysis on these logs in such a way that you can find meaningful data out of those logs? So the lab that we're going to be doing is Firewall log review. So let me go back to the directory, right? So let's go to Firewall log review. There we go. And you're going to be running your Kali terminal, and you're going to be doing the analysis using a number of just basic command line tools. We're going to be using grep. We're going to be using cut. We're going to be using our tools to do analysis, mathematical analysis on the logs. Now, the goal of this isn't like how you do analysis on ASA logs. I chose ASA logs because I hate them. I don't like working with the logs. It's a pain in the ass. And I wanted to show you what the tools are that I would use to do that analysis, like grep, cut, and R tools. Use data mesh as well. So you're going to open up your Kali prompt. You're going to become root. You're going to cd into the firewall log, and then you're going to grep out that IP address. Once again, we go back to the Cookie Monster virus. You're starting with a system, right? We have a system. We got Cookie Monster. We think it's compromised. The first thing you're going to do is make sure that there's actual data associated with the IP address of interest, right? Then we're going to pull it out of the ASA logs, and then we're doing an inverse grep. When I first did this, all of the logs had a connection to my edge router. I know that that's my edge router in South Dakota, 24.230.56.6. I know what that is. I'm doing an inverse grep. I don't care about connections to my edge router. So we're doing an inverse grep, right? Then we're going to start cutting out different fields of interest. So we pipe that through fin because that has the network end, the network where the end state, and it has data size, the connection time, things like that. We're going to cut, specify a delimiter of space, and then we're going to pull these specific fields. Then you're going to move on down and you're going to grep out specific strings of interest like this potential IP address that is compromised, which is 13.107.237.38. And the other one is kind of a weird backdoor. It alternates back and forth between two separate IP addresses. What are those IP addresses? When you're doing this lab, I want you guys to look into this and I want you to tell me what those IP addresses are. Let's do some research and figure out what's actually going on with them as well. Then we're going to focus in on the data size for 18, and then we can do some math where we're sending it through our script and our tools to give us the, what is it, the minimum value, the maximum value, the mean, the standard deviation, and the variance. All right. So that is the lab. This lab is going to take us up to and through the break. So we will resume at 10 after. So let's get rolling, and then I'll do a walkthrough. See you on the other side, everybody. Yep.
I can
So
see you, but not your screen.
yeah, Kevin, Ryan, someone? Can anyone hear me? Someone's working. Back.
I'm looking into it now, Mr. Strand.
Okay. Sounds good. Get Ryan back on. All right, so let's talk about this lab while we're getting the screen share up and running here in just a second. That's a good one with Ryan with the house on fire. All right, so the goal of this particular lab is quite simply to get you familiar with the concepts of using the tools that we use every day. I know this sounds weird. I think that a lot of people, when they think of, you know, working in a SOC or they're working in a pen testing firm, that it's all about using really advanced tools, doing really advanced elite shit. And most of the time, what you're doing is exactly what we did in this lab, where we're running grep and we're sending it through cut and we're just doing data analytics in it as well. So we're waiting a couple of seconds. So I'll just kind of like, I guess, let me see if I can do a screen share instead of my camera. I don't think I can. Let me try this. All right, there we go. Hey, are we there? Everyone, we good? All right. We're in business, everybody. Well done. All right. So let's go ahead and let's get started here. I'm going to throw this over there and we're going to open up a Kali command prompt and we're going to get started. We're going to accept the warning and disclaimer because we've never connected to the system technically ever. I'm going to make the appearance look slightly larger, more fashionably plump, I suppose. We got bold, do 16. I'm going to do something I usually don't do. I'm going to make my screen very large there. All right, so I'm going to become root and just put that in there. And then I'm going to cd into the opt firewall log directory. And then we're going to run this command. Now, I had mentioned earlier that you're always going to start with something, right? You're going to have some IP address of interest. And our IP address of interest in this is 192.168.1.6. And we're pulling it out of the ASA logs. Now, I'm going to do something a little bit, oops, there we go. I'm going to do something a little bit different. I'm going to kill this grep statement right there. And I'm just going to pull that by itself out. Now, one of the things that I probably need to add back in to the, I need to add back into this more than likely, I think, is the initial first run that you see right here. Because you see tons and tons and tons of connections going to that 24 address, and that 24 address is my edge router. So the first thing that I do, I know people's like, oh my God, my eyes, what happened? So, but this has a very valuable lesson to learn right here, right? The valuable lesson to learn off this is the IP address that I'm interested in is in here. Here, let me show you this. Let's do this instead. I'm going to change the IP address to be something different, right? So let's say it was 192.168.10.6. I got nothing, right? So if I was investigating 192.168.10.6, I know that these logs have nothing related to the system that I am currently investigating. So doing that first one, that's that initial check to make sure that you actually have data related to the system that you're doing analysis on. I know it sounds goofy, but that first step is skipped by so many people. And they spend hours trying to do analysis and they're like, I don't know what's going on. I don't know. I don't see it. I don't understand. And they don't see it because it's not there. So this allows me to start looking and saying, yes, I do in fact have data associated with the system I'm investigating. So now we do this. Great. All right. So this is much better, right? I've got the internal system, right? We've got the teardown connection, and it gives us the outside IP address over here. You can see we have 1318, 1318, 1318, and it just repeats again and again and again and again and again, right? So now I'm getting the connections, I'm getting the connection count, I'm getting the connection duration, but all of that data that I'm interested in is in the TCP FIN connections. So I'm going to go ahead and quit out of that. So now let's pull that data and let's start kind of cleaning things up a little bit, right? So I'm going to do this where we are pulling the data from the system, let's say the Cookie Monster system. We're doing an inverse grep against 24.230.56.6. We're only grepping out the lines that have FIN, and that FIN connection has how long the data connection was and how much data. We're doing cut, we're specifying the delimiter of a space, and we're pulling in the fields 1, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14. All right, there we go. Oh, this is looking good. I like this a lot. I can make it better, actually. So I can take these fields. Let's say I don't care about the date timestamp. I'm going to pull that out. Oh, geez, this is just beautiful, right? So now I'm taking this and I'm getting it to the point where I can see patterns in the data. You know what? I'm just going to keep going. I just had so much fun. I'm going to keep knocking these things out. I know it's a TCP connection. So I got connection 4. I'm going to blow those away. Oops, there we go. I actually honestly didn't think that that would work. I don't care. Well, let's go ahead. I think that we're good with the outside to inside. We have the duration in bytes. Oh, this is what this right here is what IT is all about. There's this great pyramid out there. It's what is it? Data, information, knowledge, wisdom. There's this great image that everybody has to look at, right? So when we're looking at what we are doing, right, we're taking data and we're parsing that data to the point where it can become information, right? I'm honing out, I'm like a sculptor, right? I'm taking this rough rock and I'm cutting this rock back to take that raw data and have it become information, right? And then as I'm doing this, I'm kind of working my way up to the knowledge pyramid, right? So that's what we're doing here, right? That's what we're doing. We're doing data analytics, right? We're taking the data, we're cutting it. So if we're looking at it right here, just some things that jump out at me is this alternation between 18, 13, 18, 13, 18, 13, 18, 13 is weird, right? That's strange, I guess, is what you could say. It's Not normal. Now, did anybody look up those two IP addresses? What do we know about the 13 IP address and the 18 IP address? Guys, answer that, okay? Type that in. I want to know, what did you find out about the 13? Yeah, it's Microsoft and it's Amazon. Okay, I'm going to explain what this backdoor is here in just a little bit. Also, look at the duration on these. That's a lot of very quick duration right there. Isn't that crazy? And then also look at the consistency in the data size. In fact, we can zoom in on that data size, right? I can zoom in on just one of those IP addresses. So I can take this grep and I'm just going to throw it to the end, right? I'm just going to put it right there. There we go. Oops. I'm going to pipe it through grep again. I only want to grab that. There we go. I think it doesn't like that. Let me just grab the whole thing. Let me just Control C, Control L. We'll blow it away. We'll do this whole thing. All right. So now what we're doing is we're just going to focus on one of those IP addresses, the 13 IP address. And that 13 IP address, 1 second duration, again and again and again and again. And look at these bytes. 85, 82, 82, 79, 82, 82, 85, 79, 85, 82, 82, 79. Yeah, that's just real super tight data size dispersion on that. And now we can look at 18, right? We can drill in on the 18 IP address. Let's do this, put that in there. There we go. Super tight again. 18, 16, 18, 48, 18, 32, 18, 16, 18, 16, 18, 48. We have really tight data connection sizes on those. Now I can just pull out the data size right here. And there you can see the data size is really tight. But how tight is it, right? That is where we can bring math into the equation. So for that, I do R tools, and it's going to come out and it's going to give me the minimum value, the maximum value, the mean right here. The standard deviation is only 12. So that tells me this has a really tight data connection. Now, what is this backdoor? This is a backdoor created by Black Hills Information Security. As I'm sure surprises absolutely no one at all, but this is a backdoor. It's created by BHIS. And we created this backdoor. We were using CDN, content delivery networks, and we were alternating the backdoor between Microsoft and Amazon. So if somebody was trying to investigate, they would never see the whole picture. They might think, oh, it's something weird going to Amazon, but maybe they'd miss the Microsoft. Or they'd say something weird going to Microsoft, but maybe they would miss the Amazon as well. So that is the story of this backdoor, trying to blend in as much as possible on that as well. So that is the lab. So let's go ahead and let's talk about memory forensics. And I think, Zach, are you around, sir? I don't know if Zach is still hanging out. I don't think he is. That's okay. We're going to do an Ask Me Anything, right? So we're going to do an Ask Me Anything. And then tomorrow, I can safely say, Haircut Fish, that is the worst picture of Zach that's ever been created, ever. That's spectacularly bad. The lighting, the overlay, it's really horrific. You should burn that. That's humanity is less because of that picture. All right. I also want to say it looks nothing like Zach, just to be clear. If Zach's like, do I look like that? No, you don't. All right. So memory forensics, right? So this is one of those skills that I really wish we had more people in the industry that were up on with it. I really do. And the reason why is because we run so much in a virtualized sense in so many different locations. We're running things in the cloud. We're running things in VMware. We're running things in a variety of different virtual machine environments. Almost all of these VDI environments gives us the capability of snapshotting a system. And when it snapshots that system, it also snapshots the memory on that computer system as part of that state. And the memory analysis tool that we're going to be using in Volatility has the ability to read a large variety of memory snapshot files so you can do analysis. And here's the coolest thing about this. You can do memory analysis and go threat hunting, and the attacker never knows that you're doing threat hunting. So if you're looking and you're afraid of like rootkits, right? Like rootkits that, oh, well, they know I'm doing different commands on the system. Will they detect me? Yeah, they can. But if you can do memory analysis correct, where you can snapshot the memory, you can do full forensics on that system, live style forensics, and the attacker will never see you. All right, so what do we have? So memory analysis many times can start with the network, right? We can start with the network and work that way. So we start out there because that's the best place to start. We started it with Linux, we started with Windows. We're looking for those established connections, those SYN sent connections, and those like stopped or dead connections as well, because that shows that there's some evidence of an established connection at some point in the history of that system. We can then drive in deeper and we can do process analysis as well. We can look at the individual processes on the system. Of course, letting that network connectivity guide us into what we're going to do the investigation on. And then finally, we can look at DLL and command line invocation. Not finally, there's a couple more. So remember whenever we did the task list space / M space / FI, then we put in the quotes, PID, EQ, and then the process ID. This is the same thing. We can look at the dynamic link libraries. And once again, the attacker will never see you on this computer system doing this type of analysis on it live. So, all right, so that is volatility, okay? Now, I wanted to save some time for the Ask Me Anything, and we cut it short yesterday. Had a little bit of an emergency. Had a rough couple of days. I know it sounds weird, but I had to put a cow down, and that's always tough, especially a cow that we've known and has been around for a long time. We have like milk cows and things like that. And then this morning I had a cow. I don't know how. I should have taken a picture so I could prove it. Somehow got into my bale feeder and couldn't get out. That's not something that should happen, but it did. So kind of a bit of a crazy couple of days. All right, but now I'm good to go for the Ask Me Anything. So we really like this part of it because it's kind of free form. It isn't just about the labs. You can literally ask me anything. I prefer it to be about computer security, but if you want to talk philosophy or things like that, we can do that too. That's good. So what questions do you all have for me? Got a lot of people typing here. Are you able to go over ASN? Yes. So that particular lab is going to be a lab that you will do with on the extra lab day on Thursday. So that particular lab is interesting. So with ASN, if I can find my ASN lab, have I not added it? Understanding ASNs. All right. So ASNs they are like zip codes. All right. So if you look at zip codes on the open internet, there are good zip codes and there are bad zip codes. So if we were to do this, I can actually run this really quick. It doesn't take that long. So you guys can do it later. Pull that down. I just pulled down a master list of bad IP addresses. Okay. Just really bad IP addresses. All right. So then I'm going to go through and I'm going to feed each of those IP addresses into Kimry, and it's going to create this spreadsheet that's ASN merge. So we're going to go through, grab the ASN names for each one of those IP addresses, and this is going to take a little while. But the reason why the ASNs are so critical and the reason why I like looking into it is ASNs, like there's certain ASNs that you never have malware coming from, or almost never, right? Like if we're looking at like Windows updates come from an ASN that almost never has anything bad happening on it. A whole bunch of Google IP address ranges have nothing bad that ever really comes out of it. Even like Xbox live ranges have nothing bad. But then you have some network neighborhoods, some ASNs or zip codes that are really horrific, right? Like there's a whole bunch in China that just have tons of bad IP addresses in them. And then you have other ones like DigitalOcean is probably going to be in the top 6 whenever we do this. So we're doing this dynamically for you to look into how we can investigate an ASN to see just how bad that ASN actually is. So I'm going to answer a couple more questions while Kimry answers you're like filling the stuff out. So we'll answer a couple more when it finishes. We'll kick back and we'll come back to ASNs here in just a couple of seconds. Do I like Costa Rica or Czech Republic better? Two different things. If you look at Costa Rica, Costa Rica has surfing. BHIS has a hacker house. It's available for any employee or their family to go down there at any time, no cost. I mean, I'm not covering their plane tickets and stuff like that, but the place itself is available, and it's like a 5-minute walk from the beach through downtown Samara. So I love surfing, right? But I also really love Europe. So Prague, I'm going back out to B-Sides Prague next year in 2026. Absolutely love Prague. And then the other town that I love that we have an office in is in Krakow. So love Krakow, and then in Germany, in Bavaria, we have an office there as well. So those are the places that I love. South Dakota, of course, is very high on that list, and trying to get more work in those places is a huge part of what we do. All right, so now it's done. All right, so let me show you what this looks like. All right, so this gets kind of crazy. So what we're going to do is we're going to do a count of how many bad IP addresses are in each one of these ASNs. And check this out, right? So this ASN 4837, China's backbone, has 7,888 deny listed IP addresses. That's what we call a bad neighborhood. DigitalOcean's in second, right? DigitalOcean was 7,719, and China is back again. China is back again. Google Cloud Compute is there. Microsoft Azure is there. And then we got ToteNet. I don't know where they are. Amazon, Korea Telecom, HiSet. You can see that there's a lot of China here, and then Linode is kind of down a little bit. So it allows you to understand like what the zip codes are on the internet, and it allows you to identify how dangerous a zip code is. So if you have network threat hunting, you can see whether or not that is a bad location. So there we go. All right. So, what was my favorite memorable moments of Wild West Hacking Fest? It kind of blew up in our faces, but I always love giving out the Rito Award to Tanya Janka. This year was great. Just kind of giving that to someone who kind of embodies what my mom stood for was really, really cool. The other one is always one of my favorites is the steak dinner, and then the final one is always one of my favorites, the karaoke night, which I think damn near killed me. I'm 48 years old and doing that much karaoke until what was it from like I think it was from like 8:30 until 11 o'clock at night. I was half dead on that as well. Regarding grepping fin portion of the commands, is it normal to go for this as logic behind looking for ASA logs? But remember, the goal of this lab, Jägersil, is nothing to do with Yggdrasil, I think is how it's pronounced. It's the tree of life for Norse mythology, I believe. The goal isn't necessarily ASN labs per se. It's just basically looking for the lines that have the data we're looking for and then grepping those lines out. But in this specific context, those fin lines that have the fin line, they have the duration and the amount of data that was transferred. And that's why we focused on those logs as well. You said you wish more people had memory forensic skill. If you had top 3 skill set with someone stepping into the SOC, the other 2 would be network analysis and host analysis. The Windows Live analysis, the Linux Live analysis, and networking would be the big ones that I'd be super focused on in what we're doing. What do you recommend for a home lab? This environment. You should know all of this crap that we give you for MetaCTF inside out and backwards. You should know this stuff. Like start here and then start building your own lab. Start building an Active Directory environment. Stand up your own SharePoint servers. Just basically start doing it. If you want to see something really cool, Jeff McJunkin gave a presentation on how to build a kick-ass home lab. You should stand it. You should check it out as well. Oh, Haircut Fish has a bad ASN list on GitHub, which is pretty cool because we do it live, but I like more cool things. So that's pretty neat. All right. What advice do you have for someone earlier in their security career that's trying to get into more specialized blue team role? Sec, engineer, threat hunting, cloud. Are certs more valuable? No. If you can afford certs, you should always get them. The CISSP ain't going to help you much with like a specialized threat hunting. It's going to be more of a general certification that gets your foot in the door. So it is an important certification. You should look into it, but it shouldn't be like the end state. And even though ISC Squares sometimes puts it up that way. So I would definitely look at CISSP, but then the other thing I would look at is Hack the Box and Try Hack Me, and really do as much as you can and get as far as you can with those as well. Is there a way to see when a hop goes through NSA servers? Not off the top of my head. It absolutely can be done, right? Like you can do trace route and then you can do a trace route lookup through ASNs and things like that as well. Yeah, I can't talk much. Kevin, dude, like he paces me, man. Like, he's in a punk rock band that's actually really good. I don't know if Kevin can share out some of their videos, but Kevin throws down. Like he knows how to party and get up on stage and rip, and that's really super cool. So there we go. My oldest sibling, I am absolutely. Voice is gone. You know that, yeah, I couldn't talk. But so that morning we ran 4 miles because we did the morning run at Wild West Hiking Fest. Then we did the karaoke that night. And then the next morning we were up at like 5:45 to go mountain biking another 15 miles. So it was a pretty intense few days, but it was a lot of fun. After this course, I recommend the Intro to Security and MITRE class. I recommend that one as well. As a 48-year-old trying to do a career change into cyber, 3 bits of advice. One, don't get discouraged. Two, understand that there is definitely ageism. I was just talking with a friend about this. Ageism is a thing. It absolutely is a thing. And the third thing is focus on the core fundamentals. Really don't get distracted with Rust and all the cool hacker stuff du jour. Focus on the fundamentals, the Windows command line, Linux command line, networking, get familiar with those things, and then start learning Python. I know that's a lot more than 3. There you go. What is something you would recommend just to break into Skype? I just kind of hit that same thing would apply for someone that's 48 years old as that. When you are grepping for a specific IP address, what alert would that IP address create to know to investigate? Well, the first thing is Cookie Monster would be on the screen. There would be some precipitating event. It would be like an EDR alert. It would be the Cookie Monster thing. It would be a user saying, I saw something strange like dancing gerbils on my screen. It'd be something like that. Something would cause you to start doing that additional investigation. Some malware can evade AV scans by unloading itself from memory during an active scan. The name of that tool is, oh God, Jamie Butler. Here, hold on. I feel bad. I can't remember the name of this tool, but it was a long time ago. I want to say it was 2007. Might have been Black Hat. Shadow Walker. So if you want to look at a tool that does that thing, this is one of the worst videos apparently in the history of this is one of the worst videos in the history of DEF CON. But this is a tool called Shadow Walker. And Shadow Walker watches, and that's Jamie right there. Shadow Walker watches for sequential memory reads. And then whenever it sees those sequential memory reads, it basically pages itself out of memory. And that's how it evades detection. So that is the only tool that I know of. I don't want AI mode. I want all, God damn it. There we go. So here's the PDF for it as well from Black Hat. And this is 2005. So this is 20 years ago. There you go. All right. Hey, I've had a Google account forever. So there you go. All right. So there you have it. So that hopefully answers that question, but I've never seen it in the wild, and that could be a number of reasons why I've never seen it in the wild. So there we go. I wonder what video that is. Kevin's got a couple of videos that are pretty solid that you should check out. Where do we think it's heading in regards to resources and companies? Do you think external SOCs? Yes. I do think that external SOCs for probably anything outside of the Fortune 500 is where we're headed. It's getting to the point where keeping up a security operations center, keeping up the talent, keeping up the skill set is getting harder and harder. for organizations to do. And you start developing a specialized skill, and you're starting to see a lot of AV companies that are doing SOC as well. So I kind of feel like that is where it's going. Now, I do believe the pendulum is going to swing back. I think you're going to run into a situation where people will be like, we can't outsource this, because once again, you're looking at like the F5 thing, right? How many external SOCs are being asked right now today start pulling their F5 logs for their customers? And they have no way of doing that, right? They just don't. They're like, well, we run Sentinel-1. I don't know what we're going to do with these logs. And I think we're going to see this kind of go out of the Fortune 500, and it's going to come right back in again as well. You're about to graduate college with your major being in cybersecurity, but I feel like I should spend more time and money on certs. You still have plenty of time. College is fine. Don't focus on certs. Go to cyber ranges. Hack the Box. Meta CTF, of course, we have the ACE-T certification, which we'll talk about tomorrow on that as well. So that's coming up. So you'll be able to get a cheap level cert with us. So that's something you can do. Pop missed yesterday's Q&A, so apologies. As someone who is beginning their cybersecurity career 1 month in new to Linux, I've been proactively looking things up during the training to keep up, but finding it challenging to grasp some of the core concepts. I'm wanting to make sure that I'm still focusing on the right takeaways. Well, a couple of things that I think are really cool. One, this is recorded. I think for the next 6 months, you'll be able to go into resources and rewatch the sections that you have. So once again, it's not training, and I'll get more into this tomorrow, but we're really, really focusing on how we can solve the skill gap in information security and do it in such a way that's affordable. And by doing it this way, it's recorded on YouTube. You can pull it down, you can rewatch it, you can slow it down to half speed, you can redo the labs, the slides are available to you. It's completely set up for you to kind of dig into this, because I don't believe anyone ever goes to training and comes back from training with the skills that they need to be able to do the job. So if you're looking at what we do at Anti-Siphon, it's a lot of edutainment, right? It's educational entertainment, because my primary goal as an edutainer is to try to motivate people and get people excited about this field, right? Because I could just go through nothing but stats and statistics, and that would suck for you, and that would suck for me. So it is my sincere, deep hope that you go through this and you're like, I'm going to go through that again, and I'm going to get it to the point where I feel comfortable with all the topics in the class as well. So we have, do you think more of a company to evolve into a zero trust is just where it's going to be? Working remote, zero trust essentially is you do not trust the network. Your firewall is always on. Every single service requires authentication. Kind of the end of a standard Active Directory and what we tend to see as traditional network infrastructures. So you're going to have cloud authentication. It's going to be through Microsoft more than likely. And then all your services will be accessible from anywhere, and you will not trust the network. So that is really the evolution of where things are going as well. We got 51s and 59s in here. I honestly, it's the same thing, right? You just got to get those fundamentals down. You just have to. So someone's making fun of my emails. That's fine. It's a lot of unread emails. All right. Yeah, never give up stopping learning. I think that's the key. And if you ever find yourself, pulling what is it, Die Hard 2 quote, like, I'm too old for this shit. It's time to stop and reflect. I can feel that kind of nibbling at the kind of like far corners of my psyche where it's like I'm getting too old. And I don't know, it's definitely can feel that. And of course, Brian will call me out and be like, I'm not old. And that's kind of great that Brian's around to remind me that I can always be older. And as long as that's true, that's a good thing. That's a really good thing. All right. Some more questions. Once again, stick to that certifications. We've got a document. I actually think it's in the resources. Zach, I don't know if we loaded in the ACE-T cert stuff, but we're soft launching our own certification. We'll get that out for you all here a little bit later, but we are creating an affordable pay what you can certification as well. So you can kind of get something on your resume from this class and the things that you're doing. Just trying to make things better for everybody on that as well. All right.
Posted that in the resource channel.
Yep. So go check it out. I'm full of excitement, but I would be more excited if all the people would listen to all the things we tell them. Can't make that happen. I can't help you there. Right. I can't. It's kind of weird. Like I, I know for a fact that a lot of people will listen to me because of who I am. And I know that because I've been on phone calls with people. I'll give you an example. I was arguing with a customer. This is a number of years ago. I was arguing with a customer about the CIS controls and what they meant, right? And they were going back and forth, going back and forth, going back and forth with me. And I'm like, that's not the intent of that particular control. And they said, what makes you an expert in that particular control? And you can say that that's not the intent. And I'm like, I wrote it. And I think that that's kind of okay, that is a flex. I'm not going to lie, it's an asshole flex. It absolutely is. But it's also kind of weird because there's a lot of times that people just defer to me and they're like, "Well, John says this." And that's hard because I'm afraid I'm walking around buck ass naked and everyone's like, "Hey, dude, nice cloak." It's one of those concerns that I constantly have, right? So my point to you is you're not ever going to have people that just start listening to you because you're now this wise sage. It's going to be this constant thing. And I think I'm okay with that, right? Like we shouldn't just have people that are trusted because of who they are. I think everybody should have a defensible position that is going to be a well thought out defensible position in that as well. Question: did you get TSSCI clearance with my DoD experience? I got cleared, I want to say in 2005. I'm not entirely sure. Maybe the year this presentation was written. And I got cleared at Northrop Grumman to work at the NRO and a bunch of other programs for the NSA, DHS, DNI, like a whole bunch of intelligence community stuff that I was working with at that time. And apparently I still have a clearance. I don't know. I don't know why. Don't know how. It's just one of those weird things, just kind of every
You're
once in a while.
special.
I'm special. That's
You're
right.
special.
Someday they're going to call me up. They're going to be like, John, you're done. And I'll be like, whew, that was a long ride to get to this point. Uh, what else do we have here, Zach?
I'm not sure where you are at in your
Oh
questions, if
man,
you
I'm
were
so
caught
far
up or
behind,
yeah,
dude.
I'm sure. I'm sure. There I mean there's a recent one if you'd recommend the CCNA as a good baseline cert.
Hell yeah. Any certs you can get if somebody's willing to pay for it. Now there's really expensive certs. Don't ever think that if you go to a really, really super expensive training organization, you get a really expensive cert that it's just automatically going to lead to jobs. Those days are over. So
Those days are
CCNA.
long over. But CCNA is still probably one of the most uh,
It's respected.
marketable certifications,
It's
as
very
far as they
respected.
go. Yeah, it's very, everybody knows who CCNA is, right? Or who Cisco is. So if they see the CCNA on your resume, it's going to look great for you for sure.
It does because it's not easy. It's not a pushover cert at all.
It's
So,
much better than the Network Plus.
oh my God. Yeah. So I don't know. We've had the conversations about whether or not anti-siphon should be training prep classes for some of those. I don't know if we're going to head that way or not. It's kind of strange.
I mean, we would provide the best, training experience for that type of material, though. So,
Yeah, maybe it would be fine if we could do that. And it's really just kind of a reskinning on
yeah,
some of these things too. So,
it, we definitely would have we have our spin on it for sure, and I think
for
it'd be
sure.
enjoyable.
And that would be the goal, right?
Yeah, that for sure, because some of the stuff is so boring,
Not going to talk
especially for
about
those
clearance.
certs.
Yeah. I don't know. I talk about my clearance and classified work all the time. I just know what I can say and what I can't say. Like that time that we came across a whole bunch of dead aliens. That was a lot of fun. See, I can lie about classified things all day long. And one of the things I learned in PsyOps, we had this one thing. It was kind of strange. Something that was highly classified was leaked and everyone freaked out. I'm not going to say what it is, but you could say, let's just say it's dead aliens, right? Something with dead aliens. And I remember we were completely freaking out, and I was talking to a bunch of people in DoD, and they were like, "We need to send a cease and desist letter immediately, and we need to send this out. We need to send this out, and blah 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 blah. And we need to shut this particular website down." And I'm like, "Time out, time out. The more you send out the letters, the more you try to shut stuff down, the more that you fight this, the more that you're giving it credence. What you need to do is take this exact same data, and you need to release it to the craziest, fringiest people on the internet, right? People that have like, gold foil hats because they've upgraded from tinfoil hats and they're like in their basement and they're absolutely convinced that the government's out to get, you're going to email those people the exact same crazy classified data. And then they're going to post it on their website. And what's going to happen is the credibility of that data is going to crater and it's going to go down through the floor. And that's what we did. Because we knew it was already out there. We knew it was a matter of time before it started spreading. So we just took it and spread it to like, National Enquirer level garbage on the internet. And still to this day, if you bring it up, people are like, oh, that's just a bunch of garbage. That's a bunch of crazy wackos on the internet said that that was real and that's all fake. So,
I love
all right.
that.
I think it's time. I've got to get going. I've got like 400 and some miles to drive today.
Oh,
So I've got to
goodness.
get up to Bozeman, go see
Have
my
fun with
kid.
it.
I will.
Safe travels.
Thank you, sir. All right,
Absolutely.
let's wrap it up, everybody. I'm going to stop sharing. There we go.
Thank you, everybody, for being here today. We appreciate y'all.
All right, later, everybody.
See ya.